So in the last couple of weeks, the main focus has been getting the Libra Zcash crates into releasable state because they've had a bunch of work done over the last couple of months, and we want to sort of like make sure that gets capped off and released, particularly with regards to the keystone changes that were brought in at the end of last year. There were some changes that had to flow through from further up in the crate stack and dependencies, basically to enable Keystone to get onto published versions of our crate stack rather than depending on pinned dependencies, which should then mean that future updates are then just them rolling dependency updates rather than needing to update vended libraries. So that work's been done. We are going through the release motions, not as we speak because we're all on the call, but today. And so that will
almost as we speak.
Almost as we speak. And so that will include the changes for all the no standard stuff that we did to enable Keystone. It will include the recent changes for just for well, there's other stuff that's gone in there. The transparent change recovery work is not going to be in this set of releases because that's a significant enough change to the way that the wallet code synchronizes transparent logic that we want that to be in its own breaking release change. So the PR's ready to go. And as soon as we've done the crate stack of releases, we will then be merging that and rolling that through to the mobile SDK so that Zashi, Edge, and Snopple, etc. will be able to test that and make sure that that potentially works for however they're working with their wallets. And that will also be the point at which then Zale will be able to start leveraging that, and that's probably the point at which we'll start being able to add some of the transparent related RPCs to Zale. The other thing that we did in the last couple of weeks was wrote up and put together what's now Zip 325, which is for a specification for account metadata keys. The intention with this is to enable a commonly understood key tree that any wallet that wants to encrypt or handle off-chain metadata that their wallet is generating in a way that you can recover from an encrypted backup from using the same seed material backup as you already have, i.e., the seed phrase backed up. This is something that will enable you to do that, which will be useful for Zale, for Zashi, for probably other wallets if they wish to use it. But the main motivation for doing it this way is that then the Keystone firmware will be able to be updated to export the root of that correct tree so that without needing the Keystone to be involved in all of the key derivations for that. So it's a single predictable key that they'll be able to refer to.
And by Keystone, we really mean any compatible
any hardware wallet will be able to do this. Yes, if you're any hardware wallet that wants to follow integrate with PCZTs and is doing the thing, will be able to do everything the Keystone does. But the general mechanism of when you're exporting the unified full viewing key, which is what gives you the view capability for the shielded and transparent like notes and things, they will also be able to export this account metadata key, which gives you the encryption capability for off-chain metadata that wallets might be associating with it.
Yeah. So by that metadata, we mean things like address book, annotations on transactions, what exchange rates were at the that we use to calculate amounts. All things that are necessary for tax and stuff like that.
Yeah, moderation related things. If a wallet is putting in stuff related to memos that they don't want to see in their wallet, persisting that kind of information as well. So that stack of things is what that enables. And then, just the other thing that happened in the last couple of weeks was I implemented support in the mobile SDKs for fetching and submitting transactions over Tor. So that's going to hopefully roll out. I just need to get the Swift bindings in place, but that will hopefully roll out as a capability in the mobile SDKs in their next release, which then wallets using the mobile SDKs will be able to leverage for particularly transaction submission is probably going to be the first use case for this, so that you can, done correctly and done carefully, will be able to break the link to stop light wallet Ds from directly observing who is submitting transactions on the network. You obviously need to take into account the fact that there are possibilities for timing correlations here, because if you have fetched information, like if you submit a transaction and then you immediately query it publicly via the light wallet D or information about it, you can run into problems. So anyone integrating it does need to think carefully about the patterns with which their wallet does requests. But at least the integration that we're, once we have the capability in the SDK, that's one of the things we'll be slowly working on, integrating it into the various requests that the SDK itself makes to that, beyond what the SDK supports wallets making directly.
Yeah. Tor does have limitations in its adversary model, so it's not designed to protect against global surveillance, but it does do a pretty good job of protecting against compromised infrastructure.
Yeah, and it's the simplest next iteration on this pathway. Stronger iterations would be, using things like NIM, mixnets, that approach, which is definitely something that there's interest in looking at. But this is now that we have the infrastructure behind, this is a simple step forward to lift the network level privacy.